Hello students, today we will solve some numericals and reasoning questions based on electric potential. Now say for example, first question we have taken, a point charge capital Q is there at point O and 2 points we have taken A and B. Now it is saying, say if the potential difference VA minus VB is positive, then we have to tell whether Q is positive charge or negative charge. Now if you see the diagram carefully, this is the charge. Say for example, if it is positive, so if we place any test charge at point A or at point B, then test charge is always positive, so this charge will repel that test charge. It means direction of electric field in this case will be from O to B, or we can say O to A. Now electric potential at any point is given by V is 1 upon 4 pi epsilon naught into Q upon R. So we can say electric potential is inversely proportional to distance. Now in this question it is given that VA minus VB is greater than 0, or you can say VA minus VB is positive. So in that case, electric potential decreases in direction of electric field. So value of potential at point B will be lesser than the value of potential at point A only when Q is positive. Now second question we are saying, say in this case a square is given in the question, say for example of side 10 centimeter. At the center of the square a charge 500 microcoulomb is placed and another charge is taken from this point A to point C, means diagonally opposite corners of the square. The question is saying if we take any 10 microcoulomb charge from A to C, then find the amount of work done in this case. Now if you see the diagram carefully, from the center distance of A and C is equal, and that is half of diagonal. It means point A and C, they are the same potential. It means potential difference between A and C is 0. Now work done is given by Q into potential difference. Now since potential difference is 0, so in this case work done in taking the point charge from A to C will be 0. Now third question is saying, this was there in 3 marks in the last year's paper and it was there for HOTS, you can say, means high order thinking skills. In this question, the question is saying we are having a spherical shell and that is conducting, and the inner surface is having the radius small r and outer surface is having the radius capital R, and total charge spreaded on the surface, means including inner and outer, is capital Q. The question is saying we have to find out the expression for the potential at the center of the square in this shell. अब say for example we are considering such a charge on the inner surface is small q, that means total charge is capital Q. The charge on the outer surface means Q2 will be Q minus Q1. In this case we can say that total charge Q is Q1 plus Q2. Now question is saying that surface charge density for the two spheres, inner one and the outer one, is same. Now surface charge density is given by charge per unit area. And now in this case, because sphere we have taken, the area will be 4 pi r square. So we have Q1 upon 4 pi r square, means small r for the inner one, and that is Q2 upon 4 pi r square for the outer one, and these two values are equal to surface charge densities because they are equal. So we get the value of Q1 and Q2 in terms of area of that particular sphere, inner or outer, and the surface charge density. And also we know Q is Q1 plus Q2. So we get the value of surface charge density in terms of capital Q and small r and capital R. Now potential at any point is given by 1 upon 4 pi epsilon naught Q upon R. So for inner sphere, potential is same throughout the sphere because it behaves as if the whole charge is lying at the center. So for inner sphere, the value of potential will be 1 upon 4 pi epsilon naught Q1 upon R. And for the outer one will be 1 upon 4 pi epsilon naught Q2 upon R, and net potential at the center will be V1 plus V2 as we have discussed earlier in the theory portion. So we get 1 upon 4 pi epsilon naught Q1 upon R plus Q2 upon R. Now substitute the value of Q1 and Q2 in terms of surface charge density and surface area. So on solving we get small r plus capital R bracket then sigma upon epsilon naught. So potential we have got, now substitute the value of sigma and we get the final value of potential at the center. Now next question is saying if we are having n drops and each drop is having, say for example, a potential V, and all these drops combine to form a bigger drop, then we have to calculate the potential of the bigger drop. Now you know whenever we combine the number of drops, in that case the total volume will remain the same and the whole charge will be added up. So we can say in this way the total charge on the bigger drop will be N into Q. Now we will take out the volume. You know volume of bigger drop is volume of n small drops. So we calculate the value 4 upon 3 pi r cube is n into 4 upon 3 pi small r cube, where capital R is radius of bigger sphere and small r is the radius of smaller sphere. N is number of drops. So on cancelling the common term from both the side and taking the cube root, we get capital R is n power 1 by 3 into small r. Now the potential of bigger drop by the general formula is 1 upon 4 pi epsilon naught into total charge upon radius. Now total charge is NQ and radius is capital R. Now substitute the value of capital R in terms of small r. We get n power 2 by 3 into 1 upon 4 pi epsilon naught into Q upon R. Now this value 1 upon 4 pi epsilon naught into Q upon R is the potential of a small drop. So we get the overall potential of the big drop is n power 2 by 3 into potential of each small drop. Then next question we are having, say we are having concentric equipotential surfaces of radius 10 centimeter, 20 centimeter and 30 centimeter respectively. And it is saying for the inner surface voltage is 60 volt, then the next 30 volt and the next one is 20 volt. Means in value wise it is decreasing in the as we increase the radius. Now question is saying that we have to calculate the magnitude and direction of the electric field. Now you know, for say for example if we take the surface of 60 volt, now radius is given 10 centimeter. So we know the basic electric field at any point. Wise if we calculate the potential and electric field general Y formula, you can say then electric potential is given by 1 upon 4 pi epsilon naught Q upon R. So we get 60 is 1 upon 4 pi epsilon naught into Q upon 0.1 after converting the radius from centimeter to meter. Ab say 1 upon 4 pi epsilon naught is electrostatic constant. So we are representing it by K. Then we get 60 is equals to K into 10 into small q. So we can say K into small q is 6. Now electric field at any point is given by 1 upon 4 pi epsilon naught Q upon R square. So we can say it is K into Q upon R square. So value wise we get 6 upon R square and unit is volt per meter. Now you know electric potential decreases in the direction of electric field. So we can say the direction of electric field is radially outward. Now next question we are taking, say an infinite plane sheet of charge we are having whose surface charge density is 10 power minus 8 coulomb per meter and say it is placed in air. The question is saying find the distance between two equipotential surfaces if their potential difference is 5 volt. Now you know for plane sheet of charge E is sigma upon 2 epsilon naught. So and general formula is magnitude of electric field is delta V upon delta R. In this case we substitute the values and we get value of delta R as 8.85 millimeter. And last question we are saying electric field is given in the question and 3 points are giving A, B and C. In the question it is given AC is 5 centimeter. BC is 3 centimeter, AB value is not given and question is saying we have to calculate the potential difference between A and C. Now if you see the diagram carefully, electric field is along the x-axis and BC is along the y-axis. It means the direction of BC is perpendicular to electric field. It means BC is by definition is an equipotential surface. So potential at B and potential at C will be equal. Now, if you apply the Pythagoras theorem, AB is 4 centimeter. So, we get magnitude of electric field is delta V upon delta R. So, we get delta V is magnitude of E into delta R. Substitute the value of R after converting it to meters. So, we get 5000 into 0.04, that is 200 volt. Now, we have to specify the sign also, means whether we are calculating VA minus VB or VB minus VA. अब say for example if we are calculating VA minus VB, then we are going in the direction of electric field and you know in that case the potential decreases in the direction of electric field. So potential at A will be more. So we will have the answer as VA minus VB is plus 200 volt. And if we are specifying VB minus VA, then value will be minus 200. Now in this case, because B and C are at same potential, we can say potential difference between A and C is 200 volt, and VA minus VC is plus 200, and VC minus VA is minus 200 volt. That's all for the day, and tomorrow we will take the next class for capacitors.